Hey guys, this is Miss Sheehan, and I wanted to walk you through your water on a penny lab. You'll be doing this one at home, but all you need is some way of dropping some even water droplets onto some type of coin. It can be a penny, a quarter, whatever. Just be sure you make a note of what you actually used in your lab that you perform. Okay, the very first thing you're going to do, you're going to start an actual lab write-up on this. We're going to get some good practice in on that. And in doing so, we're going to use some good AP terminology, okay, and practice those skills. So first thing we're going to do is predict how many drops of water we think we're going to be able to put on our penny before the water starts spilling off. Okay, I don't want you to put number 1, 21, okay? That's not what we're going for here. I want you to state it in a sentence. It is your hypothesis, okay? You're predicting the outcome of your lab. So, if I have a quarter and drop even water droplets on the quarter, then I should be able to get 50 drops on my quarter. Whatever, okay? Just predict how many droplets of water you should be able to get on your penny or quarter or whatever until it spills off in a complete sentence. Okay, and then we're going to explain how so many drops of water can stay on our penny or quarter without spilling over. Again, this is complete sentences. This one should be a few sentences long. Okay, this is a good explanation. I want you to use some of the vocabulary and terminology we've been looking at in our notes. So it could look something like the water will adhere to the penny, and due to its cohesive nature, it will have a surface tension allowing many drops to remain on top before spilling over. Something like that. Do not use my exact sentence, but something like that. All right, and then we're going to design our experiment. It doesn't have to be 10 steps long, okay? We're just dropping water on a penny, but this is getting you some good practice. So you'll have step 1, da-da-da-da-da-da-da. Step 2, da-da-da-da-da-da-da. Step 3, da-da-da-da-da-da. Okay, one step could be record your information, because you do need to be recording your information. So typically in an experiment, you would have different trials. So you do need to have some kind of data that you collect. So we'll just say trial 1, trial 2, however many you feel like you need to get some good data. And we'll say number of drops. Okay, trial 1, maybe we got 21, here we got 23, here we only got 19. Okay, in the end, you probably need to have your average number of drops. So you'll add all these together, and if I had just done 3 trials, I'll add all those together and divide by 3 to get my average. And in doing that, I want you to... this is using your data to support your claim. You're also going to write a conclusion, okay? So write a conclusion that states if your hypothesis was supported, if your average number of water droplets was close to 51, or if it wasn't, and what might have caused that difference. Use your data to support what you say on your conclusion. And I kind of skipped over this one. It's a little out of line. Whenever you are setting up your design here, you need to be able to identify your independent and your dependent variables, okay, and your control group. Remember that your independent variable is what is being changed, And your dependent depends on your independent variable. It's usually what you measure to show how what you changed affected your outcome. Okay, so dependent is whatever you're measuring. Independent is going to be what you change between your different groups that you're studying. That's about it. Be sure whenever you're designing your experiment, that it ties into your independent and dependent variables that are being looked at. And then whatever data, and I need some kind of chart that you make, you will support your claim by writing a conclusion that ties all these thoughts together. Okay. I hope that helps get you started. Let me know if you have any questions.